Hi everyone, welcome to the All Things XR podcast. I'm Mojtaba. In today's episode, we have Sean Gorman from Zephr. Hi Sean,
Hi, thanks for having me.
thanks very much. So Sean, can you tell us more about yourself and your background?
Yeah, I'm kind of a bit of an accidental entrepreneur from a startup perspective. I started off as an academic. I went to grad school in the U.S. in a school called George Mason University outside of Washington, D.C., and was actually doing research on digital divide and doing kind of spatial network analysis. And make a long story short, some of our research ended up getting into the news. And there was enough news trucks that showed up on campus that they sent the patent lawyers in. And when they filed patents, they told us we either had to license the patents out or start a company. And since the research was all very nascent and hacky, we figured we'd try to build something. And so um, I was the postdoc and didn't have a tenure track job, so I was the volunteer to go out and try to start the company. And so that was our first startup. That was back in 2005. And so we did that startup for about 7 years. It was a geospatial mapping startup, or it evolved into a geospatial mapping startup for web-based crowdsourced data collection and mapping. And yeah, it was an awesome run. We made a ton of mistakes and learned a lot. And that company was acquired after about 7 years, and that kind of started us on the journey of doing more things around mapping and positioning and computer vision and things along those lines.
Awesome. So Sean, can you explain what Zephr is and the problem it aims to solve?
Yeah, interestingly, the idea for Zephyr kind of came directly out of the work we did at Pixel8 previously and at Snapchat. And there we were looking at trying to crowdsource data to power a visual positioning system. And so instead of needing a Google Street View car, an Apple Look Around vehicle that are pretty expensive, we were looking at, could you use cell phones and GoPros to collect the same imagery and use that to build the future database to power a visual positioning system. And a key part of that is the GPS system on the mobile phone or on the GoPro that gives you the position of the images that you're collecting, and then that allows you to stitch them all together. Um, but started running into issues when we got into urban areas where there was a lot of multipath issues and the satellite signals bounce off of buildings, and that causes the position to drift from where you actually are. And then getting the position of the camera to line up with the pixels that it's collecting became really hard as that GPS drifted. And our co-founder, Pramukta, who is the CTO, had a cool idea about improving the accuracy of GPS. And generally, the concept was, and when you use your cell phone to get a position, it's looking up at satellites, and it's not only GPS, but it's Galileo and GLONASS and Baidu, and there's a whole set of constellations from different places, and you look across all those satellites and try to find the best position based on the satellite measurements that you can get. But when you're in a deep urban area or other challenging degraded environments, a lot of times those signals bounce and it's hard to see line of sight on the satellites, and then your position degrades and drifts off. And so the idea that Pramukta had was, well, the same way we crowdsource imagery to stitch together different views of a city to make an AR positioning database, what if we could use measurements off multiple phones to improve the satellite positioning? So while I might be indoors and only seeing a few signals, or I might be in a deep urban canyon and see a few signals, you could be across the street, say in Central Park, and you're seeing lots of satellites and getting really good measurements. And so if your measurements and my measurements could be combined, then we could use the good measurements to improve the phones with bad measurements, and everybody's positioning could get better, both absolutely and then relative distances between each other. And so that was the general concept. If we could network these satellite measurements together to create a more resilient positioning system and a more accurate positioning system as well.
Awesome. So, Sean, can you tell us a comparison between GPS and VPS? VPS meaning visual positioning systems that you're actually working on. Why would we actually need VPS when we have GPS
Mhm.
and it's covering currently all the Earth?
Yeah, and that's a really good question. And with visual positioning systems, we use those oftentimes in urban areas where GPS isn't quite as good. And the nice thing is with the visual positioning, instead of using satellites to get your measurements, you're using visual landmarks or key features that you see. So when you're building out a visual positioning system, you will take images of an area from the camera, and you might have images from multiple different cameras. But across each one of those images, at different angles that they're taken as you're moving or the vehicle's moving, you're looking for pixels in common between those images. And so there might be like, say, a stop sign in one image, and then at different angles you're seeing the same stop sign, and that stop sign is the pixels in it are common across multiple images. And so part of that stop sign might become a key feature in that database or a key point. And then you get enough of those key points into the database, then when a new camera comes along and it looks, it's going to search that database for those same pixels that were common that you know the position of. And then once you identify one of those in your camera, it can look it up into that database and figure out where you are based on the positions of those pixels or key points and where you are. And then that all works together to find a position that's reported back to the phone. So the cool thing is, cities have lots of really distinct features, and it's also where GPS struggles the most. So it's a really nice complement to make that work better. The other great thing about visual positioning is not only does it give you an X and a Y and a Z, it can also figure out your pose, what you're looking at. Am I facing this way or am I facing sideways? And that helps a lot for augmented reality because you want to know what somebody's looking at in addition to where they're located at. And so the two systems, sometimes people think of them as being two dependent things, but they end up being very interdependent in that at least the type of visual positioning systems that we worked on at Snapchat or that Google or Apple or Meta use, they're all very dependent on GPS because in order to search that database, if you have a database of all the features in a city, you can imagine how big a city is and how many features that there would be, millions, if not more. And so if you're having to search that entire database for a city or the whole globe, the time it would take to find the features that match would be quite huge. And you might also get a lot of false positives. And so you need to constrain that search space to something small and manageable so that you can do it very quickly to update positioning. So GPS is usually the trick that you use to get an initial position for where the person's at, and then you search just that immediate proximate set of tiles or features to find the match, and then you can position them within that oftentimes more accurately than the GPS did, and then you get the additional pose information and other things that are really useful for doing the augmented reality piece. So in reality, at least in my experience on these consumer level systems, the GPS and the VPS are highly integrated and very interdependent on each other. If you lose GPS, the VPS won't work. And so, the two things end up being highly correlated systems from an operational standpoint.
Great, awesome. Sean, Zephr aims to enhance GPS accuracy to centimeter levels, as you said, for mobile phones without requiring hardware changes. What challenges did you face in developing a purely software-based solution, and how did you overcome them? Can we dive a little bit more on the technical side?
Yeah, no, it's a great question, and that was a big goal for us to be able to do something that was software only. And traditionally, most of the improvements in GPS and GNSS writ large are driven by hardware. So, for instance, a few years back, they started making chips that had two bands. So instead of just the L1 band, you also had the L5 band. And if you have two bands, then you can get rid of a lot of the noise and error, especially like with the atmospheric. Um, Errors that come in from the ionosphere. And then it's also really helpful in urban areas also to get rid of some of the multipath error because you have two signals that you can work across. But that requires that a new chip be in the phone, which means if you want to have access to a new technology, you need to buy a new phone that has a dual band receiver in it. And so the adoption curve can be quite slow on that as you're waiting for new people to buy phones. And then the other part that was really important to us is that, traditionally to get improved GNSS capabilities, you need to go and buy a new phone. And so the people who acquire these new capabilities are usually the OEM and handset manufacturers. But typically, most of the benefit accrues to the people that create the apps, right? If you're creating a mapping application or an augmented reality application, or a rideshare application where positioning is challenging, um, you know, you have customers that are willing to pay or advertisers that are willing to pay to support that model, and you can align that incentive with a new and improved feature. Whereas the handset manufacturer, you have to convince your average person that having a dual band chipset is worth spending an extra $50 on the phone than not having a dual band. And for your average consumer, it just kind of goes over their head, right? They don't really know what that is, how that meaningfully impacts their life. But if you're a rideshare company, you can say, yes, we will get the driver to the right side of the street or the right level of the airport to pick you up, and you're not going to have to wait 20 minutes while they circle around to get onto the right side or the right level. Then that is a meaningful impact, and that saves those companies also a lot of money, and they have happier customers. So that was the other big driver for why we wanted to focus on software over hardware, is that one, you can bring the capability to the people that need it most, which are the apps. And two, you don't have this long adoption curve where you're waiting for people to buy your hardware. You're convincing um, manufacturers to put your firmware or hardware onto their device. You can go directly to where the demand is. Um, but that being said, there's a reason most people do all this work in hardware, because doing it in software can be quite hard. Um, but fortunately, we had one nice advantage in that Google, with the Android operating system, opened up the raw GNSS measurements for the satellites a few years back. And so not only do you get the latitude, longitude, and altitude, you actually get the raw measurements, the carrier phase, the code signal, the Doppler, all of these great measurements from the satellites. And so that creates an opportunity that if you can come up with a better mathematical model for turning those signals into a position, that you can improve what that positioning looks like. And so for us, the big mathematical challenge was kind of how to reinvent that wheel. And the particular approach we took was, let's make a big data problem instead of a small data problem. And a lot of the work we had done, at Snapchat and Pixel8 and other places was taking very large, complex computational data sets, like these really big feature databases, right? But with the satellite, with the phone, you generally just get whatever satellites you can see. That might be 10 or 11 satellites, and that's all the data that you have. And so a lot of robust new computational AI statistical tools that have emerged in the last couple of years, it's hard to bring to bear because you just don't have enough data to run against it. But if you can open that up and get data from 5, 6, 10 plus receivers, and they can each see 10, 15, 20 satellites, the amount of total measurements you can get becomes much more interesting, and you can open up a whole new set of statistical tools like robust estimation and a lot of other like really interesting methods. And so we use an ensemble processor that does an optimization around all of these things, to take all these measurements and to grossly simplify it. We try to look for the really good measurements, and we try to throw out the really bad measurements. So the satellite might be really low on the horizon, and that starts giving you funky measurements. You want satellites that are as directly over you as possible, because it's less likely they bounce off of things. And there's a lot of other factors, right? And if you have enough measurements with enough satellites, you can start throwing out the bad ones, focus on the good ones, and then get a really accurate error correction that you can individualize and send out to all the phones that are on the network. So there's another level of really hard math in there, and there's lots of really fun, interesting hard math. But to prevent rambling on forever, that was kind of the core hard problem that we were trying to solve, or at least our unique way to try to tackle a problem that's been around for a very long time.
Yeah, yeah. So, Sean, does your solution also work in indoor scenarios?
It does to a limited extent. And so
Uh-huh.
we kind of look at this as having two phases of work. One is improving performance in GNSS degraded areas, which are, urban
Mhm.
areas, or increasingly jamming and spoofing is a big problem. And so, but you still have satellite signals, they're just degraded. And that's the case for a lot of indoor scenarios. Like, right now there's a window just to my right. And if I got out my phone and I pulled it up, I would be seeing a handful of satellites through that window, or, through the roof is porous enough that the signals are still getting down to me. If I was like in an underground garage, um, and there's a bunch of concrete above me, then I'm probably getting no signals at all. And so we call that GPS or GNSS denied areas. So for the first one where it's degraded, then yes, we can 100% help out there if you're, indoors, but you're still able to see some satellites because people that are outdoors are getting really good measurements and they can help correct your position indoors so that it works better than it would all by itself. Because all by itself, I'm indoors and I can kind of see satellites. And I'm sure we've all experienced this, right? You come out of the parking garage and your blue dot is drifting all over the place, or you're inside and it's moving around, right? So definitely can help out with those scenarios in this first phase. And we're seeing those performance bumps currently in our field testing and pilots and so forth. The second phase is a more challenging one, right? Where you're completely cut off from satellites altogether. Um, but a really important one, right? I think our overall goal long term is, precise location anytime, anywhere on the Earth, and that includes indoors. And so the concept there, which is still nascent, and we're still proving it out, is that our core engine, the way that it works, is it does a set of relative distance metrics between all the devices, and relative distance is what drives positioning technology called real-time kinematic location (RTK). And so part of RTK is getting a relative distance between your rover and your base station. And since we're basically turning everybody's phone into a base station, we're getting relative distances between all those devices. And then we're using another process called PPP, and there's a hybrid that syncs together in that ensemble optimizer to figure out everybody's location using those relative distances and then also absolute distances as well. So the concept for the indoor piece of it is that if you can get a relative distance measurement between somebody that's outside and somebody that's inside, then you can use that to solve for that person's location based on that existing network. So, kind of a crude metaphor is thinking about, we have a geospatial coordinate system that gives you latitude, longitude, and altitude. And if you're outside, satellites help solve for that. Here, basically what we're saying is we're going to take that outdoor system and project it indoors by tethering it to folks that are in that indoor location. And so as long as you have a relative distance measurement between the device from indoors to outdoors, then you can begin to solve for that. And you could daisy chain multiple people indoors. So that might be, Bluetooth low energy, that might be ultra wideband. Those both have range limitations that are a little bit challenging, but the new 5G technologies that are coming along and the comms channels within that have really excellent terrestrial ranging. So we think as those technologies come online, there'll be some really good opportunities to piggyback on them to also solve for the indoor location, which is a great one because it's if you can interconnect those two seamlessly, indoor and outdoor, then you have a really nice holistic approach to the problem versus carving them off as two distinct things, right? And you're using like beacons indoors, and then you have to switch back over to GPS outside, and you have to hand off between the two. And we looked at a lot of this at Snap and at Pixel8, and those things are challenging, right? Really, what you want is a ubiquitous spatial coordinate system that works everywhere. It's just that doing latitude and longitude inside is hard because they can't see the satellites. So if we can tether to the satellites, then we can make that all work quite well.
Yeah, yeah. I myself, at my own company, we are working on an indoor localization technology, and we actually patented it. And we're
Cool.
using deep learning with gathering data set from all over, for example, a mall, and we did the localization for that specific place. But actually, in our journey with that technology, we realized that we are actually competing with very much larger companies, and we might not have a chance there. And after a while, we stopped the project. So one of my questions for you, Sean, was that what is your strategy to avoid being disrupted by a much larger company, or competing with them with your resources, and what would be your edge? What would be
Mhm.
a company like yours what would be the edge of a company like yours in this competition?
Mhm. No, it's a wonderful question, and it's a challenge that's definitely front of mind for us, right? We're a small team, and there's huge players in this space. You have Apple and Google that both provide positioning at the operating system level. You have the chipsets within their phones that come from Qualcomm and Broadcom and MediaTek primarily, and they provide the hardware GNSS positioning within that. Um, and then you have the apps that are operating on top of that. And those apps can be absolutely massive. Somebody like Meta or Snapchat or Niantic for that matter, all have huge businesses built on top of these fundamental operating systems that are very critical around the positioning piece. Um, but I think, at least from our perspective, the approach to dealing with those is one, being open about what we're doing, working collaboratively with those companies, leveraging the assets they make available, like, Android's raw GNSS positioning is critical for us to be able to do what we do. Um, and then, moving quickly, right? I think, one of the, cool things is when Google opened the raw measurements, they also had a Kaggle challenge, right? And so they're inviting people to come help them solve this problem. They have an appetite for solving the problem. You can generally assume if Google's having this problem, then other people are having this problem. And then it's, a matter of, can we as a small, nimble group that have a niche set of expertise specializing in this area, can we move fast enough to come up with creative ways to solve this problem in a new and novel way? And I think, what helps is that, again, traditionally, the way this problem is solved with hardware, right? And so the approach and the teams and the composition to doing it are all hardware based. And so when you come in with a software team, and that software team's skill set is, doing computational AI and dealing with large complex data sets, and is applying that kind of unique skill set to geospatial data. If you want to go and do that as a large player, you have to figure out how to get, people from your AI ML teams and uh, work with a hardware team and figure it all out, right? And having spent time in a large company, that's really hard, right? Especially in a time where you're not hiring and headcounts are generally frozen or growing slowly. Organizationally, trying to take a radically different approach to doing positioning from where you're invested in today is a pretty big organizational pivot. Um, and I think that's, a bit of where we have some opportunity, right? Of like, we don't have those constraints around us that we can completely take a blank slate to this and rebuild it from the ground up. And in the process of doing that, it's been really interesting because we found, errors within some of the core measurements and components in this that we don't think people realize that were there. And when we corrected for those errors, we started getting really good results. We're generally, having these raw measurements, I think people initially saw that, oh, with these raw measurements, we could do RTK on the phone. But that really hasn't panned out either in academic work or industry work. And I think, that's some of the advantages of taking kind of a radically new approach to something, is that not only do you get the opportunity to take a novel um, mathematical journey and adventure, but you also get to kind of reassess the problem from the ground up and look at things people probably haven't looked at in a long time, because it's just assumed that that's the way that it works and that's the way it's operated for the last 3 decades. I think the combination of the two has really allowed us to find some really interesting opportunities within the problem set and come up with something novel. Obviously, continuing to execute on that, demonstrating in the real world, getting it to work in real time as well as in batch processing. There's still lots of work to be done, but I think generally how we try to compete in these spaces with these really large companies is taking that philosophy to the problem set and looking for these opportunities where other people might not be looking, or it's just difficult to invest organizationally because it requires moving too many ships, or too many chairs around, so to speak.
Yeah, yeah, yeah. Completely understand that. So Sean, can you share your journey from founding Pixel 8 to its acquisition by Snap?
Yeah, it was a really fun journey. I think, similarly, we had been before that working in a company called Maxar that operates, the satellites and creates the imagery for most of the mapping applications we use, whether it's, Google Maps or Apple Maps or Mapbox. All of them get their, kind of global satellite imagery base layer from Maxar, including actually Snapchat as well. And And as part of that, we got into doing 3D mapping. And one of the things we got interested in was looking at the intersection of using those 3D maps for these new emerging workspaces like augmented reality and autonomy. And you could use the 3D maps created from satellite imagery to do to power these new applications. So similar kind of visual positioning problem, right? Could you use the satellite images to find those key features that we talked about previously? The problem is, the satellites are way up in the air, and most navigation is done terrestrially from a first-person point of view, and satellites are way up, and so a lot of them just don't have the angles or what they call nadir um, of them being low enough. And as they get low, you get more error. And something like if you've ever zoomed into like Google Earth really close down, it kind of looks like melted butter because of the photogrammetry. A lot of it comes from satellite and aerial imagery, and it's really hard to do that. Um, and so the thought we had was, well, what if you took ground imagery and combined it with aerial and satellite imagery so that you have really good views from the top. And the other good thing about aerial and satellite imagery is the accuracy is generally pretty good, better than GPS, especially aerial imagery or aerial LiDAR. So the general idea was, could you take these data sets that had an aerial view that had really good accuracy, but the wrong perspective, and they're not updated very often. And then you had ground imagery that has the right perspective and is updated all the time. So if you combine the accuracy with the update and the perspective and blend those two things together, you could have the best of both worlds. And so that was the general concept that we built Pixel8 around, adding in the crowdsourcing, right? Because if you have this good reference to paint from the ground, then maybe you don't need a street view car, maybe you don't need a look around car. You can just use your users on the ground to paint your structure there. And so the cool thing is that actually ended up working quite well. We did work with a couple of the different big companies doing AR stuff at the time, and I think the challenge was we were hoping that there was going to be an AR explosion, right? That the investment in the headsets and glasses were going to happen pretty quickly, and it wasn't going to be just these big 6 or 7 companies that were investing in AR. That there would be all sorts of folks that needed constantly updated 3D map of the globe in order to operate AR at scale. So unfortunately, the headset and the glasses didn't come along, and so kind of looking ahead and trying to figure out how we're going to grow our customer base without kind of that breakthrough to enable it. We couldn't see it, and so when there were some early acquisition opportunities came along, we ended up taking one of those and going with Snapchat, which was wonderful because we got to work on doing this at city scale. They have hundreds of millions of users that are collecting imagery all the time, and so that was a cool experience to work on those problems, at scale with real world users. So that was kind of the journey that we took. We generally try to be very pragmatic about the startups, right? It's uh, some things are maybe could be home runs, some things are base hits, and you just have to kind of be realistic about where your idea is positioned and what's the best way to return value to the founders and the investors when as things evolve, which I'm sure is probably a similar journey you had with the indoor location side of things.
Yeah, yeah, exactly, exactly. So, Sean, the applications for improved GPS accuracy are vast, from navigation to augmented reality, as you mentioned. Which industries do you see benefiting the most from your technology?
hmm It's a great question. I think originally we thought that the app providers would be the biggest drivers, and they certainly, have a really large appetite, and there's lots of opportunity there. But we've been kind of surprised with, where some of the opportunities have popped up, for things like collision avoidance between, cars and pedestrians. If you have a really precise location for a car and a person, then you can use those to avoid them from hitting each other. And that was interesting. One of our early investors was SRI International, and they were the ones who did all our simulation and benchmarking on that. And we also licensed an early patent along with our own internal patents. And part of that was doing relative distance between vehicles for doing collision avoidance. Um, and so, that was an interesting, concept that we began to look at that, we hadn't thought of at all going into it. That these positioning technologies could really be a public safety driver. And not only looking at the traditional use case of having cars avoiding hitting each other, but also looking at how pedestrians could also, and bicyclists and motorcycles and things that traditionally don't have onboard GPS or GNSS capabilities. Um, so that's been interesting to see, some of those opportunities. There's also been ones that I'm kind of going with ones that have been total surprises that we haven't thought about. The mobile app stuff has been wonderful, and really good feedback on that has been very positive. But there's also been these really fascinating surprises. And the other one has been, in a lot of these emerging conflict zones where jamming and spoofing are causing a lot of problems um, for public safety applications, aviation, things along those lines, that it ends up that the same approach where we're throwing out bad measurements because of degradation because of big city urban canyons, it's the same thing when you have spoofing and jamming. If you have multiple devices networked together, you have a much better chance at detecting when that spoofing and jamming is happening and ejecting it and returning a proper position, or figuring out where the jamming or spoofing is coming from, so that that safety issue can be addressed. So that one was really interesting. We had some folks inbound asking about applying the capabilities to these new use cases, and so it's been exciting to learn about and understand, and just see. It's just a good reminder of how important GPS and GNSS is to modern society from a safety and security, as well as just a practical convenience standpoint. There's so many interdependencies on it, at so many different levels, that was, I think, in the back of our head we knew it, but we've been so focused on augmented reality and visual positioning for such a long time, that it was actually really fun and exciting to kind of see about all these other different ways that it's used, and potentially ways that we can help out with that going forward.
Awesome, awesome. So, Sean, your entrepreneurial journey is very exciting. What advice would you give to aspiring tech entrepreneurs who look up to your achievements?
Yeah, I think a big one for me is finding an idea that you're really passionate about. Um, so I think at the end of the day, anytime you do a startup, it's going to be hard, right? And you're going to
Yeah,
fail way more than you succeed. And there's going to be lots of challenges that you never imagined. So you should work on something that you really enjoy working on. Because unless you really, really enjoy the problem space and what you're doing, the challenges and friction can kind of beat you down, right? And so I think it's important to find, not something you just think is going to make money or something that's going to make you rich, um, because it's kind of I think a not sustainable motivation for doing a startup, especially a tech startup or a deep tech startup over a long period of time. That has to be something that you truly care about. So I think you need to have that kind of attachment to persevere through the challenges. And the same thing for your team, right? You want to recruit people that are really passionate and care a lot about the problem that you're trying to solve. Um, because the team is, in my experience, is the biggest determinant of success or failure. That a really good team that is cohesive and very passionate about what they're doing will be able to pivot and adapt and figure out a solution that the market needs and is going to create traction and be delightful for users and so forth. Um, and most likely, whatever your initial idea was isn't going to be right anyways. You're going to have to evolve it and change it. So building that team, having a problem space that you're really excited and engaged in, kind of gives you the foundation you need to build on.
great. So, Sean, where do you see Zeph in the years to come? And what is your vision for the company?
Yeah, I think it goes back to, providing, accurate and resilient location anytime and anywhere. Starting with these degraded environments, and providing, better precision, but evolving it to working indoors, outdoors, any kind of different structure, if there's spoofing, jamming, all the different things that make GPS challenging, can we put together a resilient cooperative infrastructure that makes that bomb-proof for society? And I mean, bomb-proof is probably the wrong metaphor. That makes it, safe and secure for everybody because we've become so dependent on it. You just look at these
Yeah.
economic studies that shows, billions of dollars a day in loss if GPS system goes down or GNSS more broadly. And, trillions of dollars that have accrued just to the US economy since GPS was built out. That has become so ingrained into the fabric of our lives that, if we can provide that software layer that makes it truly safe and secure and really accurate and evolving to these new use cases, things like autonomy, things like augmented reality, where we're going to need more precision, more stability. That seems like a really good contribution to make at a societal level if we can pull it off.
Yeah, sure. So Sean, how can our listeners find out more about you and Zephr?
Yeah, we have our website, Zephr.xyz. Thankful for the domain lining up with the coordinates. Um,
Yeah.
and we have some information there. We also have a blog on Medium and on LinkedIn
Mhm.
and Twitter and so forth. And I think the exciting thing for us is we're getting really close with our real-time client, which will allow testing in the real world. Currently, we've largely been doing batch processing jobs where we're just testing accuracy and use cases. So collect a bunch of data, push it up to the server, it improves the accuracy and the positioning, and then we push out a bunch of statistics and maps and results showing how that compared to ground truth. But with the real-time client, we'll be able to take that same mathematical structure, put it on the client, and improve your position in real time. And the cool thing there is not only is it up or improving the position in real time, but it's doing it without knowing where you're actually at, which is why it's all client side. So the server and all the mathematics is just sending a correction down to the phone. So we don't know where you are. We're just providing you the correction to improve your location when you're solving those equations locally on the device. So having that out there for the most interesting use cases happening in real time is exciting. So we'll be hopefully announcing that soon and teeing up pilots so if folks are interested in testing that out. We're obviously excited to talk to them.
Sure, sure. I will shortly put links on the description of the podcast and the YouTube channel. Sean, it was great having you on the All Things XR podcast. Thanks very much.
Well, thank you for taking the time and the interest in the team's work. They really appreciate it, and just awesome to get a chance to share all the good stuff they're doing.
Thanks very much.